Hi everyone, this is my team. This is Sanjay, this is Sandeep, this is Shakti. This is our project Smart Fan Data Integration known as Quantum Flow. Actually, this is a fan which actually works on a temperature difference which is given by user as well as the room temperature.
Problems with conventional fans such as energy waste and no proper remote control, which cannot sense fire in case of emergency, and zero safety layers.
Actually, our fan is fully eco-friendly as well as environment friendly, which has fire suppression to put off fires as well as Bluetooth app and Wi-Fi app also to establish communication between the fan and the user, as well as electric sensor and TMP117 sensor to detect the environment temperature, and Peltier module for AC control as well as steam.
Now let's look at the system architecture. In input layer, we have temperature sensor which detects the ambient temperature of the room, and then since the data have the processing layer which has Arduino Uno R3, and that does all the control logic, filtering sensor, and all it compares all the basically every mean reading that's needed, and then that data is sent to the output layer which has VLEC fan, which is controlled by the VWM module, which will then ambiently adjust the speed of the motor according to the ambient temperature of the room, and then we have RGB LED which is controlled by the user.
This is how our project works step by step. First, sensing. The TMP117 or LMTP sensor senses the room temperature. Then comparison. After sensing the temperature, it's going to Arduino Uno as well as ESP32, which compares the user given temperature and the room temperature. If the user given temperature is greater and with a huge difference, the motor will be set off to speed as well as to low based on the user temperature and detected temperature. The motor 2 is for putting off the fire extinguishing. If places in fire, there's a chemical which will be sprayed on the room to put off the fire immediately. Peltier control to give steam as well as AC cooling based on the temperature.
So Bluetooth communication remote control. So this slide is fully based on the app. So our app features wireless protocol, which means it is controlled by the Wi-Fi and Bluetooth. So you can access it in both communication protocols, and we have RGB LED control commands, which means there will be a RGB wheel, so which can be controlled by the user for custom preferences, and the temperature data reception is basically the ambient temperature versus the user set temperature, or the concept of thermostat. And lastly, serial monitor and debugging. This is basically for the developers, or if you want to analyze the temperature of the ambient room and the target temperature.
Now for the key features of our fan, it has Bluetooth and Wi-Fi control, which we can use to control the speed of the fan and the RGB LED interface. We can control it using Wi-Fi. The LCD information sensor gives us the temperature and fire safety system as my friend is doing. Now for the hardware, we have controllers Arduino and ESP32. Actuators are BLDC motor and RGB LED strip. Sensors are LM35 temperature sensor and I2C LCD. Components, Peltier module, etc. Now we use Bluetooth protocol to communicate with the device. Sensors and display specification. Actually, we are using TMP117 as the main temperature sensor, which detects the temperature, and versatile system as well as the fire extinguishing, which will spray a chemical when the room is in specific fire. Peltier module, which has AC as well as steam produced in different areas for different temperature, and RGB LED specification. The fan has inbuilt light, which user can also give a custom light to be blown to make the room more beautiful. As well as LED display interface to show real-time temperature as well as the time and latest updates into it. Now, what's next with our project? We are trying to bring AI predictive cooling, clouds, and smart home and humidity and air control to our project. We are trying to bring it to residentials, healthcare, server rooms, and agricultural services. Future development roadmap. Actually, we are planning to develop our project by enhancing display and sensing as well as advanced cooling mechanism while continuing with Peltier module, as well as service and maintenance will be providing it when our project is done with and when we are with the lab. And extended connectivity. Was from Wi-Fi and Bluetooth, we are establishing more communication and smart home integration. While connected with AI and other applications, it will be with the smart home. Thank you.
QuantaFlow prototype. RGB light and Wi-Fi controlling. BLDC fan speed control. Room temperature adjusting via Wi-Fi. Peltier cooling and steam. Fire extinguishing. Thank you.